Okay bachcho, so today we will see, this is the continuation of our previous class, motion in a plane 2D, but in today's class we will be discussing a very important concept, which is projectile motion, right? So before I go to the detailed discussion of this projectile motion, I would like to give you a brief introduction what is meant by projectile motion, right? So what is projectile motion, or what projectile motion is all about? Say for example, first and foremost we will take a case. You take a simple case, something like this, okay? This is the case I am taking, and what we are doing here is, I am just, so this is the ground level or the horizontal, right? So from here I am throwing an object like this, okay? I am throwing an object like this, which is making an initial angle of theta with the ground. So I said this is the ground, this is the ground, right? From the ground you are throwing it, throwing something like this, ऐसे कि हम लोग फेंकते हैं ना चीजों को, तो just like that you have thrown it, okay? And from the ground with the horizontal, your initial velocity, okay, of the object is making an angle of theta, right? Now what is going to happen? Simple, from our simple day-to-day experience we can say that what is going to happen is, ये ऑब्जेक्ट ऐसे करके मूव करते 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 it is going to, you know, fall something like this, okay? So the object is going to fall after it has moved a substantial distance. This we all know. Now the thing is, if I tell you that now ये तो होता है projectile motion, projectile from the horizontal, okay? So we have thrown it and the object has fallen. Now there are, from this projectile motion, various kinds of problems are asked in your examination. Say for example, you will be asked to find out what is the total range. तो range हम किसको बोलते हैं? इसको हम range बोलते हैं. Range means up to what distance. So say for example, you have thrown an object from here, okay, point A. Point A से लेके the object is basically falling at point B. So the range we will say is nothing but AB. AB is my range. कितना दूरी the object has moved, है ना? तो उसको हम लोग range बोलेंगे. You can be asked about the range of the object. You can be asked about the height also. Height किसको बोलेंगे? You see, this is nothing but the height, okay, maximum height. So the maximum h is the maximum height up to which the object has traveled. This is h. ये सब आपसे पूछा जाएगा. तो यहां पे हम लोग without any formula, okay, we are going to deal the projectile motion. First and foremost, let us forget about the formulas. I'll tell you the formulas. There are certain formulas like maximum height के लिए, range के लिए, time of flight के लिए, we'll be seeing them anyway. Time of flight means the total time. For example, you have thrown the object from A, okay, from point A you have thrown it. Now this is at t is equal to 0, and it is basically coming back at point B at a particular time t is equal to t. Now this total time is called the time of flight. ठीक है, कितने टाइम तक वो ऑब्जेक्ट ने was in air, हवा पे था, कितने टाइम तक उस ऑब्जेक्ट ने हवा पे था, उसको हम लोग क्या बोलते हैं? टाइम ऑफ फ्लाइट बोलते हैं. सो विल सी ऑल दिस थिंग्स, बट फर्स्ट एंड फॉरमोस्ट लेट अस अंडरस्टैंड कि यहां पे हो क्या रहा है. व्हाट इज हैपनिंग हियर? वी नीड टू अंडरस्टैंड दैट. यू सी व्हाट इज हैपनिंग हियर. इफ द इनिशियल वेलोसिटी, if my initial velocity is basically u is the initial velocity with which I have thrown the object, okay, I can break this u into two parts. First rule projectile ka, you break the initial velocity into two parts. One is, if this is angle theta, you can very easily write that u can be broken down into two parts. What are the two parts? One is ux, u along the x-axis. X-axis means my horizontal axis. This is my ux, u along the x-axis. So one is along the ux, that is nothing but u cos theta. We have seen that. Okay. Another is u along the uy, along our y-axis, which is this axis. है ना? So this axis, which is nothing but u sin theta. So you can directly break it into two parts, the initial velocity, and we have just broken it. अच्छा, ये तो रहा एक. Second thing you must remember is that what is the acceleration? Let us now check the acceleration. When this object is traveling from this point A, ये travel करता हुआ यहाँ से लेके it is traveling up to point B. Now in this entire journey, what is the force which is acting on this object? There is just one force which is acting on this object, which is the gravitational force. Gravitational force के अलावा कोई भी force उस ऑब्जेक्ट के ऊपर एक्ट नहीं कर रहा है, एंड वी आर एक्चुअली टेकिंग द एयर फ्रिक्शन टू बी जीरो. उसको हम लोग नेग्लेक्ट करते हैं यहां पे, ठीक है ना. तो अपार्ट फ्रॉम द ग्रेविटेशनल फोर्स, नो फोर्स इज एक्टिंग ऑन द ऑब्जेक्ट. सो द ओनली एक्सीलरेशन दैट इज गोइंग टू टेक प्लेस इज बेसिकली माई जी. और जी का डिरेक्शन किस तरफ होगा? यू सी अप टू दिस पॉइंट, सो द जीज डिरेक्शन इज ऑलवेज कांस्टेंट. एट एनी ऑब्जेक्ट यू टेक, the direction of g is going to be vertically downwards only. है ना? So that is going to be the direction of g. So ux के along, मतलब कि x axis के along या फिर horizontal के along the horizontal. Okay, is there any acceleration? No, there is no acceleration along the horizontal. And along the vertical there is an acceleration, but it is in the डाउनवर्ड डिरेक्शन. तो हम लोग बोल सकते हैं कि इफ दिस वर्टिकल वी आर टेकिंग दिस डिरेक्शन एज द पॉजिटिव, ओके, देन डाउनवर्ड इज गोइंग टू बी नेगेटिव. सो आई कैन से दैट इट इज माइनस जी जे कैप. ओके, सो द एक्सीलरेशन इज अलोंग द वाई विच इज माइनस जी जे कैप. सो दिस इज प्लस, this is the positive side I am taking, and this is I cap plus I cap, this is plus J cap, this is minus J cap. Okay, इतना तो हो गया. तो I have come to know about, I have split the initial velocity into two parts. One is the ux, another is the uy, and I have also come to know about the acceleration. है ना? अब मेरा और एक very very important rule I want you to understand. जब आप एक्स एक्सिस के बारे में सोचोगे, इज वेरी इंपॉर्टेंट पॉइंट, प्लीज रिमेंबर, जब आप एक्स एक्सिस के बारे में सोचोगे, व्हेन यू आर थिंकिंग अबाउट द हॉरिजॉन्टल हॉरिजॉन्टल वेलोसिटी और व्हाटएवर, हॉरिजॉन्टल में तो एक्सीलरेशन जीरो है, लेकिन हॉरिजॉन्टल वेलोसिटी एंड थिंग्स लाइक दैट, यू फॉरगेट अबाउट वाई. एक्स के बारे में सोच रहे हो, फॉरगेट अबाउट वाई. वाई के बारे में सोच रहे हो, मतलब दिस एक्सिस यू आर टॉकिंग अबाउट, forget about x. Okay, now let us see one by one. Very very simple. First and foremost, if I try to tell you that, okay, please tell me what is the velocity, what is the velocity, initial velocity, है ना, या फिर what is the equation of the velocity of this projectile at any particular time, what it is going to be? It is going to be, you see, if I write the velocity, so the velocity is going to be, और या फिर हम लोग यहां पे u भी लिख सकते हैं, let us write it u. U is going to be what? ux plus uy, right? So my ux is what? U cos theta. U cos theta. And this is along the positive x. So I am taking it as I cap. है ना? So is there any acceleration along the x-axis? Along the horizontal, is there any acceleration? No, there is no acceleration along the horizontal. So this u cos theta is constant. So ux is constant. Okay, so your u is going to give you u cos theta I cap plus, what was my initial acceleration about the y axis? Initial acceleration is u sin theta. But this sorry, not the acceleration, I'm sorry, initial velocity is u sin theta. This is the initial velocity along the y axis. अभी हम लोग y axis के बारे में सोच रहे हैं. So y is nothing but u sin theta. Now you see this u sin theta will change with time, na? Because if I am talking about the vertical velocity, the vertical velocity के ऊपर तो acceleration भी काम कर रहा है. और वो एक्सीलरेशन किस दिशा पे काम कर रहा है? इट इज एक्चुअली एक्टिंग इन द ऑपोजिट डायरेक्शन, राइट? सो इफ यू वाई इज इन दिस डायरेक्शन, इफ आई से दैट दिस इज द डायरेक्शन ऑफ माय यू वाई, ओके, द जी इज एक्चुअली वर्टिकली डाउनवर्ड, सो इट इज डिक्रीजिंग माय यू वाई. सो फ्रॉम द न्यूटन्स इक्वेशंस ऑफ फ्रॉम द लॉज ऑफ इक्वेशन, okay, I can say that v is equal to u minus gt. So that we are going to put here u sin theta minus gt j cap. देखिए, the entire velocity I have basically split up in a vector form, and this is the vector form, which is the velocity, net velocity is basically u cos theta I cap plus u sin theta minus gt j cap. So I cap is along the x axis, j cap is along the y axis. Okay, now from here what I can say, I can tell you one thing. Take the value of g to be, say for example 10, हम लोग 10 पकड़ लेते हैं. So let us consider g to be 10 meter per second square. Let us see. Then my u is going to be how much? U cos theta I cap plus u sin theta minus 10 t j cap, right? Minus 10 t j cap. अब I am going to tell you something very important. What is happening? Just try to understand that. Forget about the formulas and everything. This is at any instance. If you know this equation, you can find out the net velocity at any instance, because you see this t value is basically there, t term is there. T term क्या define कर रहा है? That is at any point of time. At any point of time you put the value of t there. Say for example, if I say that what is going to be my velocity, total velocity at a time t is equal to 0. At a time t is equal to 0, you will put t is equal to 0 here, okay, and you will see that this is nothing but my total velocity will become u cos theta I cap plus u sin theta j cap. At a time t is equal to 1, it is basically u cos theta I cap plus u sin theta minus 10 j cap. At a time t is equal to 2, it is u cos theta I cap plus u sin theta minus 20 j cap, right? Like that it is heading. अब from here, if I tell you that this much of information you have derived, now tell me what is the time of flight? What is the time of flight? मतलब यहां से लेके ये प्रोजेक्टाइल ने इतना कवर किया, टाइम कितना रहा? टोटल टाइम, okay, what is the total time that has been taken to cover this? How will you find out? See, at this highest point what is happening, I want you to understand this. ये जो top point है, at this point what is happening? At the highest point, the y term, the velocity, vertical term of the velocity, u का जो vertical term है, vertical component है, that is becoming 0. And here only one component is acting, which is the horizontal component, which is my ux. Please understand. Here my uy is 0. Only ux is basically coming into play. So you put this is for my uy. So ये जो है इसको हम लोग 0 पुट करेंगे. So you can put, say that u sin theta minus gt is equal to 0. Right? So from here you get t is equal to u sin theta by g. Okay? Now, लेकिन ये क्या आया है? This is the time taken to reach from A to C. If this is my point C. So this is the time taken to reach from A to C. Now the time taken to reach from A to C, equal time is going to be taken to reach from C to B also. Okay? A to C जाने में जितना टाइम लगेगा, C से B तक आने में उतना ही टाइम लगेगा. So my total time of flight, I can say time of flight is going to be 2 times of t, which is nothing but 2u sin theta by g. This is my time of flight. So this is the time of flight that you have. Okay? So हम लोग कुछ भी निकल सकते हैं. You don't need to mug up. You can basically find out anything. So when I'm going to discuss about the time of flight. There हम लोग देखेंगे कि time of flight is going to, see from here only you can see. So this is, if this is my time of flight, which is 2u sin theta by g, then the time of flight is dependent on what? It is dependent on u, it is dependent on g, g is constant anyway, है ना, and it is dependent on sin theta. Sin theta मतलब it is dependent on theta. Theta मतलब it is dependent on at what angle you are projecting it. So now tell me, sin theta is going to be maximum at what angle? कौन सा एंगल पे sin theta maximum है? Sin theta is maximum at when theta is equal to 90 degree. Then this time of flight is going to be what? This is going to be maximum, and that is going to be 2u by g. और ये कौन सा केस है? In our motion in one dimension we have seen 2u by g. You are projecting something just like this. That is exactly what it becomes now when your theta becomes 90 degree. That means you are vertically throwing something. It will go up and it will come down. What is the time taken? 2u by g. That is going to be the time taken. Okay? So you see from the projectile motion also you are getting the same formula but with a theta. So because यहाँ पे angle आ रहा है. So this is entirely the velocity we have split. Okay? Now here if I talk about the time of flight, like we have said, again I am going to tell this here कि यहाँ पे हम लोग split कर रहे हैं. We are splitting it. So you see that u x is going to be u cos theta, ux is going to be u cos theta, and uy is going to be u sin theta. Up for the time of flight, first and foremost what you do, okay, to find out the time of flight, you see the time of flight I said na, how you will find out at this highest point, okay, which is the h. Here my uy is going to be 0. So you just put uy 0 there. So final velocity of y component is becoming 0. So you will get only, so it is u sin theta minus gt is becoming 0. Okay. So y component I am equating it with 0. Then what you will get, the t value or the time to reach this point h, you will get as u sin theta by g, and the time of flight is going to be the total, means यहाँ से यहाँ तक पहुँचने के लिए और यहाँ से यहाँ बैक करने के लिए. So time of flight is nothing but 2t, which is 2u cos theta, sorry, 2u sin theta by g. This is my time of flight. Okay. So this you can write as the time of flight. And you see this time of flight is dependent upon theta value. Okay. And as I said that this time of flight is going to be maximum when cos theta is maximum, that means theta is equal to 90 degree. Now let us see what is the range. We will see what is the range. Range means they are asking about this. है ना? So think how to find out the range. So range you can find out like, to cover, range is covered in which direction? Range is covered in horizontal direction. So it is only the x direction we should be considering. We should be considering only in the x direction. So you see what is the velocity along my x direction? Ux. And what is it? If it is u and this angle is theta, then I can say that it is nothing but u cos theta. This is the velocity along the x direction. Now the range or the distance covered is how much? S is equal to ut plus half gt square. But is there any acceleration here? No. So acceleration is becoming 0. So S is equal to ut. And what is the t here? T means what? From here actually the particle is going all and then falling back. So here the t is nothing but the time of flight. The total time, na? The total time is nothing but the time of flight. So I can say that range is equal to ux into t, where t is nothing but time of flight. हम लोग बोल सकते हैं इसको. So just you put the value here, u cos theta into what was our t value, time of flight, 2u sin theta, है ना, by g. So your range is becoming u square, अच्छा, 2 sin theta cos theta, I can say to be sin 2 theta, u square sin 2 theta by g. This is the range that you are getting. Now you see, look at this. Here you can say one thing, okay sir, so what are the things on which my range is actually dependent upon? What are the things on which my range is dependent upon? My range is going to depend upon u, initial velocity, because u is there. It is going to depend upon g, but g is anyway constant. And it is going to depend upon sin 2 theta. That means theta. व्हेन आई कैन हैव मैक्सिमम, आर मैक्स कब मिलेगा मेरे को, आर मैक्स कब मिलेगा, जब साइन टू थीटा इज गोइंग टू बी मैक्सिमम. व्हेन साइन टू थीटा इज गोइंग टू बी मैक्सिमम, जब टू थीटा इज गोइंग टू बी मैक्सिमम. And what is the value of theta at which we get maximum sine of that? It is, we know, 90 degree. So 2 theta has to be 90 degree. That means theta has to be 45 degree. You please write it. Let us light it here only. Think visible. Yes, visible. Okay. So sine 2 theta. Sine 2 theta has to be equal to 1 for R max. For R max, sin 2 theta has to be equal to 1. That means 2 theta has to be equal to 90 degree. That means theta has to be equal to 45 degree. So maximum range आपको कब मिलेगा, जब you are actually projecting something at an angle of 45 degree. 45 डिग्री एंगल को मेंटेन करते हुए जब आप कोई भी चीज को आप प्रोजेक्ट करोगे फ्रॉम द हॉरिजॉन्टल, दैट इज गोइंग टू कवर द मैक्सिमम रेंज, राइट. डायरेक्ट क्वेश्चन कम्स फ्रॉम दिस कॉन्सेप्ट, सो प्लीज नोट इट डाउन. ओके, right. So we have covered time of flight, and now we are going to cover the maximum height. हम लोग ये भी देखेंगे कि maximum height कब reach करेगा, when it is going to reach the maximum height. You see, maximum height पे क्या हो रहा है, again the same concept. What is happening when my height is maximum? Maximum height का मतलब क्या है, I am talking about this. Okay. So this is the height h I am talking about. Now what is happening here when it is reaching the maximum height? When it is reaching the maximum height, at that point my y component is becoming 0. Y component of the velocity is becoming 0, because here I just have one component which is ux. मैंने डिस्कस किया, अभी हम लोगों ने देखा सिर्फ और सिर्फ ux है, यहां पे uy इज 0, तो हम लोग वही पुट करेंगे. ओके, सो इट इज लाइक so this is, I can say vy square, I can say. Okay, so vy square, final velocity along the y axis, vy square is equal to uy square minus 2gh. Why minus? Because g is in the negative direction, that is why minus. So you can write it. So this is 0. So 0 is equal to uy is what? Uy is u sin theta. U sin theta का square minus 2gh है ना. So you will have it like u square sin square theta minus 2gh is equal to 0. So h is what you are getting, u square sin square theta by 2g. This is the maximum height that you are going to get. So this is the maximum height. h is equal to u square sin square theta by 2g. Similarly, आपको maximum height, this is the h value you are getting. Now h किसके ऊपर डिपेंड करेगा? h डिपेंड करेगा u के ऊपर, which is the initial velocity. h is going to depend upon g, and h is also dependent upon the theta. Right? We can say that h is dependent upon the theta. और maximum कब होगा? जब sin square theta is going to be 1. When sin square theta is going to be 1, when theta is equal to 90 degree, तभी h max होगा. उसका मतलब क्या है? h max कब होने वाला है? जब when you are just throwing it something like this, okay, vertically upward, तब theta is going to be 90 degree. right? So H max, you can write it here, H H max is nothing but u square by 2g. देखिए जब किसी भी चीज को मैं वर्टिकली थ्रो करूंगा ऊपर, that is the exactly height we are getting from our motion in a straight line also, equation from motion in a straight line, right? Okay, now let us read this sum. I want all of you to read this sum, because this problem is a very, very special problem. It is very special problem, and because why I say this problem to be very special, this is combining multiple concepts together. Say for example, it is combining, you can see vectors, it is combining the concept of relative velocity, and on the top of that it is a projectile motion or an inclined plane problem. So it is combining multiple problems together, and this kind of questions, standard questions, are asked in JEE. So I want all of you to actually read this, and then we will see how we are going to solve it. Okay. Now what the question is saying? The question is saying that a boy is moving up an inclined plane with a velocity 3I plus 4j. So that is the velocity of the boy when he is moving up an inclined plane. Okay, let us draw. Whatever information you will get, firstly you should draw it. So this is the inclined plane, suppose, है ना? This is suppose the inclined plane, and this is my horizontal level. This is my horizontal level. Now the boy is moving up an inclined plane with velocity 3I plus 4j. Okay. According to this boy, it is raining with a velocity 2I minus 8j. What it means? According to this boy, what is the implication of this word? It means that the velocity of the rain with respect to the boy is 2I minus 8j. So you have, I can write it from here, you have V B1. Why B1? B1 means nothing but the velocity of the boy when he is moving up. That is given to you as 3I plus 4j. Okay. And according to this boy, it is raining with a velocity of 2I minus 8j. So velocity of the rain with respect to the boy when the boy is moving up, this I can say that VRB1 is nothing but 2I minus 8j. 2I minus 8j. Okay. From these two informations are given to you, and from these two information I can safely find out the velocity of the rain, purely the velocity of the rain with respect to the ground. Why? How? Because you see from here, if I say that VRB1, velocity of the rain with respect to the boy, is nothing but velocity of the rain minus velocity of the boy. Can I say this? Okay. From relative velocity concepts. So VR is going to be, that is the velocity of the rain purely with respect to the ground, is going to be VRB1 plus VB1. Okay. So this VRB1 is how much? VRB1 is nothing but 2I minus 8j. And what is the VB1? VB1 is nothing but 3I plus 4j. Okay. So you have the velocity of the rain, you have the velocity of the rain to be 5I, okay, minus 4j. So this is the purely the velocity of the rain that you have got. This is the velocity of the rain that you have got. Now, this is the first part of the question. Now, what they are saying, see, find the velocity of the rain according to the boy. That means the velocity of the rain with respect to the boy. If he was coming down with twice the speed on the same inclined plane. Now the boy initially was moving up like this. So his velocity was like this. Now it is saying that the boy is coming down. So his velocity now, new velocity is going to be this. So the direction is just the opposite. Moving up के लिए जिस दिशा पे होगा, now coming down के लिए obviously velocity is direction is just going to reverse or change. And the magnitude wise it is twice. तो ये अगर v है, ये अगर vb1 है, तो magnitude wise twice means I can say that it is -2 vb1, है ना? Right? Let us see. So now with that vb -2 vb1, I need to find out the velocity of the rain with respect to the boy when he is coming down. Okay, this much of information to I have. So what I can write is that vb2, that means when the boy is coming down, that is nothing but -2 vb1. Okay, that is nothing but -2. What was my vb1? vb1 3i plus 4j, 3i plus 4j. So I can say that vb2 is nothing but -6i minus 8j. This is my vb2. Okay, and I know the vr value. The vr is how much? Vr is 5i minus 4j. So Vr, velocity of the rain, is 5i minus 4j. Okay. Then what is going to be the velocity of the rain with respect to the boy when he is coming down? That is nothing but Vr minus Vb2. And that is nothing but, what is this? Vr is what? 5i minus 4j. Okay, minus of Vb2 is how much? Vb2 is minus 6i minus 8j. So you have Vr is nothing but you have 11i, okay, plus minus 4 plus 8, so 4j. This is your what is being asked here. And this is our final answer. So velocity of the rain with respect to the boy when he is coming down is 11i plus 4j. Magnitude you can find it out, root over 11 square plus 4 square, root over 11 square plus 4 square, and also direction also you can find it out. Tan theta with respect to the horizontal, it is going to be 4 by 11. So theta is tan inverse 4 by 11. Okay. Now you see, read this. The angle of projection at which the horizontal range and the maximum height of the projectile are equal. So this is just a formula based question. So for example, if I take a projectile like this, let us suppose this is my projectile, I am projectile. So something like this. So it will have some height and it will have some range. Now if the height is h and if the range is r, they are saying that h is equal to r. For what value of theta my h is going to be equal to r? So h you can find out. H is what? Let us first find out the h. H is nothing but, at the h you are having the vertical component of the velocity as 0. So you can say that u square sin square theta minus 2gh is equal to 0. So h you are going to get as u square sin square theta by 2g. This is your h value. This is your h value. And similarly, you can find out the r value. what is going to be the r value? Range is going to be like ux, u component into t. So u cos theta into t, that is the time of flight. So 2u sin theta by g, this is the time of flight we know. So your r value is going to be I can say 2u square sin theta cos theta by g. Let us put in this form only. So now you equate these two. U square sin square theta by 2g, h is equal to r. So that means u square sin square theta by 2g is going to be equal to, what was my r? 2u square sin theta cos theta by g. 2u square sin theta cos theta by g. G getting cancelled. U square getting cancelled. Sin theta. Yes. So you have tan theta. From here you can write that sin theta by cos theta is nothing but tan theta. So tan theta is equal to 4. Tan theta is equal to 4. So theta is nothing but you have tan inverse 4. Right? So this is the answer, where your range is going to be equal to the time of flight, height of the maximum height. So option C is your correct option. Now I want you to read this. Okay, this is a question which says that a body is projected with speed 40i plus 30j. Find maximum height we need to find, time of flight we need to find, range we need to find, velocity after 2 seconds we need to find. Okay, velocity at the end of the journey we need to find, and displacement after 2 seconds we need to find. So only the speed value is given to you. So this is a very important concept. We will see that if speed value, just the speed value is given to you, how we can find out all this. Okay, first and foremost let us find out the maximum height. So you see, you just draw the projectile here. So it is like this, and your u is nothing but 40i plus 30j, है ना? So this is your u. So what is happening at the maximum height? At the maximum height, what is going to happen? At the maximum height, so I can write this entire u value, I can write it to be like this: 40i cap plus 30, so that is v is equal to u minus gt. So u is 30j, but acceleration due to gravity is in the opposite direction, so I can write 30 minus gt. Okay, in case of g I am taking it as 10. Let us suppose it is 10 only for the sake of simplicity. So 30 minus 10t into j cap. This is the velocity, right? Now at the maximum height, what is going to happen? At the maximum height पे क्या होगा? Maximum height पे आपका ये जो t है, the entire j cap is going to be 0 na at the maximum height, like I said that earlier also. So if this is the maximum height, h, what is happening at h? Exactly at h your uy is becoming 0. Okay, so you put the uy 0 here. That means what you need to put is at maximum height, at maximum height 30 minus 10t is equal to 0. So your t becomes basically 3 second. So you are getting the, at a time of t second, the 3 second, you are reaching the h, maximum height. है ना? Now you see, you put for the, this is the y axis na. So if you put the value of t is equal to 3 here, you will get what is your maximum height along this y axis. So you put it, now put t is equal to 3 second here in 30 minus 3t. So 30 minus 10 into t, right? So that gives you the velocity is going to be 0 here. So yes, the velocity is 0. This is your nothing but vu, so vy. Now you see maximum height का मतलब क्या है, y is equal to, maximum height का मतलब क्या है, y I can say, or h, whatever, s is equal to ut. So initially it was 30 ut, t is 3 second, okay, ut minus half g is 10 into t square. So this I can say as 3 into 3 t square, right? So that means s is equal to ut minus half gt square. So this is going to be 90 minus 45. Okay, 90 minus 45. So your maximum height is going to be actually 45 meters. So h is your 45 meters. H is the maximum height. And if you put the value of t is equal to 3 there, you will get this value as 0. This is how we have find out. So ये अगर value t is equal to at 3 second, you are reaching the maximum height, then what is the time of flight? The time of flight is going to be 2 times of this t. So 2 into 3, that is going to give you 6. So time of flight, very simple. Like we just saw that t is equal to 3 second, where t is to reach maximum height. To reach the maximum height. So time of flight is equal to 2t, which is equal to 6 second. Range, exactly. So now you find out the range. Range means what? Range is ux into the time of flight t. So ux is how much? 40. It is constant. Into time of flight is how much? 6. So 240. 240 meter is going to be our range. Velocity after 2 seconds. You see the velocity equation is given to you. V is equal to 40I plus 30 minus gt, that is 10t j. है ना? Now the velocity after 2 seconds, just put t is equal to 2 here. So it is going to be 40I plus 30 minus 20 j. So the velocity is going to be 40I plus 10 j. So this is the velocity after 2 second. ये velocity आपको मिलेगा after 2 second. ठीक है? Velocity at the end of the journey. Always remember at the end of the journey, अगर 30 starting velocity हम लोगों का था 40I plus 30j, at the end of the journey same velocity ही रहेगा magnitude wise, but क्या होगा, you see the value of this y axis velocity or Vy is just going to be opposite, means direction is going to be changed. Okay, so the velocity at the end of the journey is nothing but 40i plus 40i minus 30j. Okay, anyway you can also find it out. Say for example, if this is your projectile, okay, so what is happening? It is theta angle. It is going, moving up, like this, and falling back like this. Okay, it is falling back. See, what I mean to say is that this can be basically split up into two. Any point you can split the velocity into two. एक है Vx, एक है Vy. At this point also I can split the velocity into two. Vx and Vy. Similarly, यहाँ पे क्या होगा? Vx is going to be constant, but the value of Vy is going to be downward. यहाँ पे क्या होगा? Vx is going to be constant, value of Vy is going to be downward. तो इनिशियली मेरा Vx इस दिशा पे था, Vy इस दिशा पे था. फाइनली आके क्या होगा? सेम होगा Vx का दिशा, बट Vy का दिशा उल्टा हो जाएगा. Right? You can solve it equation, I mean from the equation also. If you like have this equation, the velocity equation is given to you. I would like to solve it here. Okay, velocity equation is given to you like 40i. Okay, let us write the entire equation. 30 minus 10t into j. With respect to time I am writing. Now the total time of flight is 6 seconds. So for the velocity equation, entire velocity equation at the end of the journey, you have to take the time t is equal to 6 seconds. So if you see at time t is equal to 6 seconds, what is it? It is 40i plus 30 minus 10 into 6 is 60j. So ultimately you are getting 40i minus 30j. So this is Vt. See, exactly this what I said. So this is starting velocity was 40i plus 30j, ending is 40i minus 30j. Velocity at the end of the journey, yes. So velocity at the end of the journey is going to be 40i minus 30j. Okay. Okay. Read this. What it is saying, the velocity of a projectile at the initial point A is point P. The velocity is 2i plus 3j. Its velocity in meter per second at point B. ये starting point है, ये ending point है. The velocity is going to be 2i minus 3j. Got it? Okay. Okay. So this problem you have where it is said that the speed of a projectile at its maximum height is half of its initial speed. So what they are saying is, suppose we have a projectile. We have a projectile like that. है ना? So this is the projectile and it is going like this. Okay. So initially the speed was u. At this point h, this is my point h, highest point. यहाँ पे I have told you several times that uy is going to be 0. Only one velocity is going to be there, which is ux. Okay. So ये जो ux है, that is nothing but if this is making an angle of theta, I can say that ux is nothing but u cos theta. So ux is equal to u cos theta. And क्या बोला गया है, ये जो ux है at this highest point, that is equal to half of its initial speed. तो initial speed मेरा कितना रहा, u. ये ux is nothing but u by 2. That is exactly what is given in your question. u getting cancelled, उसका मतलब क्या है, cos theta का value is half. So theta का value is 60 degree. Okay. Now we have a concept of projectile from a height. Okay. Say for example, what it means is that, say for example, there is a pillar, and from the top of the pillar you are basically, like till now we discussed projectile from a ground, this is projectile from a height. So from the top you are throwing something, है ना, you are throwing something, then how it is going to move, इसका movement कैसा होगा, it is going to move like this and ultimately it will strike the ground. Okay, we all know this. This is going to move like this and ultimately it is going to strike the ground. So this is called projectile from a height. And you see here what is happening, like if you are projecting something from the ground horizontal, making an angle of theta with the horizontal, then your u is at an angle. So it has both the components uy as well as ux. But when you are projecting something from here, from a top, initially you have only the ux part. You do not have uy. But with time your uy increases, and it increases in the downward direction, isn't it? Because at each and every point your g value is downward only. है ना? So here, if I ask you that what is my range, this is called the range here. Okay, what is my range? You will say that range is nothing but ux into t. So same thing, ux is not changing. यहाँ पे also the x-axis velocity is not changing, but the y-axis velocity is changing. So you see ux into t, that is going to be my range. T is the time of flight. Time of flight आपको कैसे मिलेगा? How we will get the time of flight? Time of flight you will get like initially your uy is 0. So you can say that v, finally you will have something na. Time of flight, if you know that this is height, then you can say that h, that is the height, is equal to ut plus half gt square. Ut is 0 plus half g into t square. This is nothing but, this is the time of flight square, right? So h is equal to, h is nothing but the distance covered. H is equal to ut, uy into t. Uy is 0 na, so that is why ut plus half gt square. So t square value, so t square you can say that is nothing but 2g, sorry g nahi hai, it is 2h by g, 2h by g. So t you are getting as root over 2h by g. This is the value of the time of flight. Now here for the range you just put ux, जो भी component है आपका, ux multiplied by root over 2h by g. This is going to give you the range. Okay. So this is a very good problem. Two projectiles of same masses and with same velocity are thrown at an angle of 60 degree and 30 degree with the horizontal. Then which will remain the same? Which will remain the same? Which of the following will remain the same? So we have a projectile like this, which is thrown at an angle of 60 degree. Suppose this is 60 degree. We have another projectile which is thrown at an angle of 30 degree. Okay. You see, out of all this, if you basically look at the range equation, it is u square sine 2 theta by g, right? This is the range. Now you look at this sine 2 theta. Sine 2 theta I can write as sine 2 times of 90 minus theta. Okay? This can be written, sine 2 theta is nothing but sine 2 times of 90 minus theta. It's the same thing, sine 180 minus 2 theta. Okay, so you see sine 60, here sine 60 is nothing but sine 2 times of, so I can say from here that sine 60 is nothing but it will come to be sine 30 by this logic. So sine 60 is equal to sine 30. That means my range, if you talk about the range of the projectile, this is a very, very important conclusion which we can draw for the range of the projectile. That 90 minus theta, you see, if the range is at an angle of theta, if you are projecting something at an angle of theta with the horizontal, and you are projecting the same thing at an angle of 90 minus theta, in both the case, your range is going to be the same. So projecting something at an angle of 30 degree and projecting something at an angle of 60 degree, in both the case the range is going to be the same. So range of projectile is going to be the same, right, in a circle. So the entire motion is taking place around a particular point. If I take this point, अगर आप लोग इस point को center मानते हो C, the entire motion is basically taking place around the center, or we can say that the entire motion is taking place around this point C, right? यही है circular motion. When a particle revolves around a particular point, so I have a particle and this particle is revolving like this around a particular point, so I will call it nothing but circular motion. Now when I am talking about circular motion, certain things I need to specify here. Say for example, I need to specify certain things. Say for example, you just look at this circle. So I am drawing a circle here. Okay. Now this has got a center point C. Okay. Now suppose there is a particle P which is basically moving from this point. The particle is moving from P and it has moved to P dash. Okay. Now just in case of, if I am talking about linear motion, हम लोग क्या बोलते हैं? Linear motion के टाइम पे हम लोग क्या बोलते हैं कि displacement, right? Displacement is nothing but what is the change in the position of the particle with respect to the original position. What is my final position? That we say as the displacement. यहाँ पे देखिए, यहाँ पे हम लोग जो मेजर करेंगे सर्कुलर मोशन में वो भी डिस्प्लेसमेंट ही है, बट हियर वी कॉल इट एंगुलर डिस्प्लेसमेंट, राइट? एवरीथिंग एंगुलर इज गोइंग टू कम बिकॉज अल्टीमेटली इन सर्कुलर मोशन व्हाट वी आर डूइंग इट, वी आर मेजरिंग द एंगल, कितना एंगल से घुमा है, कितना एंगल से रोटेट किया है, दैट वी विल लाइक टू मेजर हियर. इसीलिए in case of displacement you just say angular displacement, in case of velocity you just say angular velocity, in case of acceleration you just say angular acceleration. हो गया circular motion. So let us understand. Suppose, okay, I tell you that this angle is basically my theta. Okay, it has moved by an angle of theta. It has moved by an angle of theta, and at time t is equal to 0, this particle was, so at time t is equal to 0, this particle was at point P, and at time t is equal to t, this particle has gone to point p dash, है ना? So what is the net displacement of this particle? The net displacement of this particle is nothing but the angular displacement. The angular displacement of this particle, which is measured by this theta only, right? And if I ask you that ठीक है, ये तो net displacement हो गया जो कि angular displacement है, how much angle it has rotated, by how much angle it has rotated or moved, है ना? Now if I say that what is the velocity of this particle, then also here in circular motion we talked about that velocity हम लोग कैसे measure करेंगे? The velocity is going to be ultimately measured by the, we will call it angular velocity, and we define angular velocity omega, and omega is nothing but the change in the angular displacement by the change in time, delta theta by delta t. So this delta theta is analogous to the displacement of the particle only, okay? And another thing you must remember is that in circular motion all the thetas are generally measured in radian. So full revolution means 2 pi radian, okay? So it is starting from point P, it has moved like this, like this, like this, and again it has come back to point P. That means 2 pi radian it has covered. So you can say that 360 degree rotation is equivalent to 2 pi rad or radian, but the SI unit is always radian. Most of the things, most of the times we'll be using radian, right? Now what is meant by time period? What we call the time period? Time period is nothing but the time taken, the total time taken for a particle to complete one revolution. Say for example, you can see from here also, time period refers to the time taken by an object or particle to complete one full revolution or one complete cycle along a circular path. So that means if I take this, suppose my particle is starting from point P, it has started from point P, okay? Let me take a proper circle only. Okay. Now suppose my particle has start from point P, okay, and it has start from point P, and from point P it has traveled all the way like this, like this, like this. This is the way it is basically traveling, है ना? This is the way it is basically traveling, and it has again come to this point P. It has again come to this point P. So then what is the total angle covered? It is 360 degree, right? Now the total angle covered is 360 degree or 2 pi radian. What is the time taken to cover this 2 pi radian? That is what we are going to call as the time period. So you can write another definition for the time period. The time taken by a particle to cover 2 pi radian. This is called the time period, okay? Now after the time period, ठीक है, इतना तो पता चला. अच्छा, another thing which you should remember from here is that we are talking about the time period here. Now what is omega? Omega is the speed. It is nothing but 2 pi by time period. Omega is the circular angular velocity. So omega is 2 pi by time period. Now from this you can basically see that if the time period is increasing, if my time period is increasing, my omega is decreasing. That means very simple, you can say it yourself only. Time period increases, increasing का मतलब क्या है? Time period increasing means that this particle is actually this particle is taking more time, to complete one revolution. एक revolution complete करने पे ज़्यादा time ले रहा है. This particle is basically taking more time to complete this revolution, है ना? So if the particle is taking more time to complete a particular revolution, then we can say what we can say about the velocity of this particle. That particle is slow. Taking more time means same thing. You just apply it. You can analogously think of linear motion as well. Okay, so if you are thinking about the linear motion, when a particle takes more time to cover a particular distance, then we say now the speed of the particle is less or the velocity of the particle is less. Okay, when you are talking about the displacement. Similarly here, so here the particle is taking more time to complete one cycle. So definitely my omega is going to be less when my t is going to be more, and vice versa. Now when I talk about frequency, frequency is what? It is the number of revolutions completed in 1 second. Okay, so suppose a particle is moving and I say that the frequency of this is moving, it is having a circular motion, and I say that that particle is having a frequency of 100 hertz. So you just remember hertz, Hz. This hertz is nothing but the SI unit of the frequency, right? This is the SI unit of frequency. If I say that the particle is basically moving around a circular path and its frequency is 100 hertz, what it means? It means that it is completing 100 revolutions in 1 second. Got the point? So I can say that there is a relationship between frequency and time period. Very simple. Time period is nothing but 1 by frequency. है ना? Time period is nothing but 1 by frequency. Or you can also say frequency is equal to 1 by time period. Mathematically also, if you think, you will get this only. Okay. So omega, I said that what is omega? Omega is 2 pi by time period. Okay. This was my omega. Now this omega I can also write as 2 pi into frequency. Okay, because 1 by time period is nothing but frequency. So omega can be written as 2 pi f, right? So this is also a very, very important relation which tells you that when my frequency is more, when I am increasing the frequency, actually my angular velocity is increasing. Okay. Now you see, now I will be talking about angular velocity. Now what is angular velocity? Angular velocity is nothing but it is actually measuring the rate of change of angular position with respect to time. What is simple velocity? Linear velocity. Linear velocity tells us about the rate of change of displacement with respect to time. Okay, how the position of a particle is changing, okay, with respect to time, right? So we can say that it is nothing but ds by dt or ds dt, where s is the displacement. Similarly, here I said that instead of displacement we are going to take just the angular displacement. So if you have a circle something like this, you have a circle like this. Suppose a particle has covered, so suppose okay, so suppose this much is what is my theta 1. Okay, this is theta 1. From P to Q is theta 1, and from Q to Q prime, this is basically my, not the from Q to Q prime, I am sorry, from this entire section is my theta 2. I can say. So this angle is theta 1, P, O, Q. This angle is theta 1 and P, O, Q prime is basically theta 2. And suppose from this has, I mean from theta 1 to theta 2, in order to move from theta 1 to theta 2, the particle has taken time from t1 to t2. So at t1 time it was at q, at t2 time it is at q prime. So I can say that angular velocity of the particle is nothing but delta theta, that is the change in the angular displacement divided by delta t, right, divided by delta t. So omega is going to be theta 2 minus theta 1 divided by t2 minus t1, which is the time taken, right. Now if you have this, if you know this theta 2, if you know this theta 1, and if you know t2 and t1, very easily you can find out the omega. Now I want to emphasize something very important here. Okay, इतना तो पता चला कि ओमेगा इज द एंगुलर वेलोसिटी, ठीक है सर, और भी पता चला कि ये होगा हमारा मैग्नीट्यूड. ओके, गॉट इट. बट ऑलवेज रिमेंबर दिस इज द एवरेज एंगुलर वेलोसिटी आई एम टॉकिंग अबाउट, बिकॉज यहाँ पे थीटा एंड डेल टी बोथ आर लार्ज एंड डेल्टा टी, आई एम नॉट सेइंग दैट डेल्टा टी टेंड्स टू 0. सो ये हो सकता है कि t2 is equal to 4 second and t1 is equal to 1 second, yeah, 2 second. So when the difference, if I am taking t2 to be 4 second and t1 to be 2 second, then the delta t is 2 second, and 2 second is not something very small. We cannot say that 2 second tends to 0. Okay, so this is average I am talking about. Delta theta by delta t is nothing but average. Now here I have said one thing. Here basically I have said one thing. What I have said here is that कि यहाँ पे it is angular velocity. Now if it is angular velocity, that means ये तो magnitude हो गया. Along with the magnitude, it will also have some direction. Direction भी तो होगा ना. What is going to be the direction? Now you try to understand. Suppose the particle has moved from point P to point Q, या फिर from whatever you say P to Q prime. Ultimately it has moved. So in which direction it has rotated? We find it out by right hand rule. Okay, what you will do, simply you will put your right hand like this, ऐसे करके. You are going to point the fingers of your right hand towards P, like OP, ऐसे करके. You point the fingers, and in which direction the rotation is basically taking place. Okay, in which direction the rotation is taking place? From P to Q. You curl your fingers like this, from P to Q. P से Q rotate कर रहा है. What is the direction of your thumb? The direction of your thumb is vertical to this board and coming out. This is called coming out of the plane of the paper. So this gives you the direction. The direction of your thumb actually gives you the direction of the angular velocity. Okay, similarly, so you can say, so there is a convention, like ये कैसा movement है, ये anti-clockwise movement है. So when the movement is anti-clockwise, we take the direction of the angular velocity to be positive. क्यों positive ले रहा है? देखिए, there is nothing to, you know, by heart in physics. Physics is a subject which should not be by heart. So everything is logical in this subject. So you see, पॉजिटिव हम लोग क्यों बोल रहे हैं कि इफ इट इज एंटी क्लॉकवाइज रोटेशन इट इज गोइंग टू बी पॉजिटिव, क्योंकि देखिए ना, आप राइट हैंड थंब रूल से देखिए, यू आर जस्ट कर्लिंग योर फिंगर्स टुवर्ड्स द रोटेशन, है ना. नाउ इन विच डायरेक्शन इज द एंगुलर वेलोसिटी? Angular velocity is perpendicular to the plane of the paper and coming out of the board. So this is the positive we take, and if it goes inside the board, it is going to be negative. Like when it is going to get inside the board, if there is a rotation of clockwise, है ना, clockwise rotation जब होगा, if instead of this kind of rotation, if the particle would have rotated like this, तब क्या होता? It is going inside. You see the thumb. it is going inside the board. So the angular velocity would have been negative. The direction of the angular velocity would have been negative, है ना? And you see this obviously velocity का SI यूनिट क्या होता है? मीटर पर सेकेंड. यहाँ तो मीटर नहीं होगा, या यहाँ पे क्या होगा? रेडियन. So what is going to be the SI unit of omega? Radian per second. Nothing to say about it. Rad per second. Okay. Now they are asking you to find out the angular velocity. देखिए ये जो ओमेगा था ना, इसको हम लोगों ने कैसे डिस्कस किया? इज नथिंग बट डेल्टा थीटा बाई डेल्टा टी. बट आई टोल्ड यू कि दिस इज नथिंग बट द एवरेज एवरेज. I told you this is nothing but the average angular velocity, average angular velocity. So if my delta t tends to 0, I can say that this is average. Okay, let me. Omega is equal to delta theta by delta t, and this is average. Now when my delta t tends to 0, I can say that omega, then at that time I am finding the instantaneous angular velocity, and I can write it as d theta by dt or d theta dt. When you can say that is when delta t tends towards 0. Okay, so here they are actually asking us to find out the instantaneous angular velocity only. So theta value is given to you. Theta is equal to, like, theta is equal to 3t square. So angular velocity instantaneous, I am going to find it out, d theta by dt. So if you differentiate it, you are going to get 60. So this is the instantaneous angular velocity that you have got. Now from here, just tell me one thing. Sum तो हो गया, ठीक है. You will write it as the answer. Got it? यहाँ पे अगर I ask you that what kind of motion it is showing? Is it showing you? What should I say? Is the velocity, angular velocity, constant? Is the angular velocity constant, or is it changing with respect to time? Definitely you can see that angular velocity is a function of time. So at time t is equal to 0, your angular velocity is how much? 0. At time t is equal to 1, it is 6 radian per second. At time t is equal to 2, it is 12 radian per second. At time t is equal to 3, it is 18 radian per second. So it is continuously increasing. Velocity is continuously increasing with respect to time. Okay, velocity continuously increasing with respect to time. So this is basically a non-uniform circular motion, right? Because it is continuously increasing with respect to time. Okay, average angular velocity, we have already discussed. It is the total angle covered by the total time taken. That is the average angular velocity. Okay. Now we come to a very, very important concept, which is called the angular acceleration. Now angular acceleration is nothing but, it is basically rate of change of angular velocity. Okay, rate of change of angular velocity. So angular acceleration, if you call it as alpha, you can say that alpha is nothing but d omega by dt. So at what rate my angular velocity is basically changing, that is going to give me the alpha value. And acceleration भी यहाँ पे कैसा होगा? Acceleration का भी direction है. Say for example, if there is a circle like this, and I tell you that a particle is at point P, है ना, and it is like accelerating. Accelerating means what? Its velocity is increasing. And if constantly the omega is increasing, then obviously acceleration alpha, we will say that acceleration is supporting this omega. That is why acceleration is in the direction of the omega. That is why the omega is constantly increasing, or the speed is constantly increasing. Say for example, just the previous sum you see. What happened here? Here with time the omega is constantly increasing. So here I can say that the alpha, or the angular acceleration, is supporting the omega, or the angular velocity. It is supporting the angular velocity. Now as alpha is supporting the angular velocity, I will say that the alpha, the direction of the alpha, or the angular acceleration, and the omega are in the same. Okay, they are in the same direction. And if my omega decreases with time, then what is going to happen? If my omega decreases with time, the alpha is opposing my omega, right? Now find angular acceleration. They have asked you to find angular acceleration. So you see theta value is given to you. So you know theta is equal to alpha minus 2 beta t plus gamma t square. So omega is going to be my d theta dt. Differentiate it once, you get minus 2 beta plus 2 gamma t. Okay, alpha you get d2 theta dt2, and it is going to be my 2. So this is your basically the value. This is the value of alpha that you are getting. Okay. So this alpha, as you can see, it is not dependent upon time. No time is, so this alpha you can say that it is basically constant, which is 2 gamma. This is a constant alpha that you are getting. Okay, constant value of the acceleration. Okay. Now omega can be different for a body about different points. Okay, these things we are going to see in more detail in our rotational motion. Right. So we'll be covering in a greater detail. Now here is a very important concept that I need to tell you. If I am talking about acceleration, if you suppose I say that there is a circular motion that is taking place. Okay, there is a circular motion taking place, and this body is actually, this is the body, body A, it is revolving around this circular path. Okay, like this it is revolving. Now I will have two accelerations here. One is called the centripetal acceleration and another is called the tangential acceleration. This I will call as AT and this I will call as AC. Centripetal acceleration is always towards the center, okay, center, point C. And another is the tangential acceleration, which is the AT, which is at a tangent to this point, A point. Two accelerations will be acting here. Centripetal acceleration का काम क्या है? At each and every point, it is just changing the direction of the velocity. Centripetal acceleration is just changing the direction of the velocity. Okay. So at each and every point, the direction is going to be changed. क्योंकि देखिए ना, यहाँ पे at point t is equal to 0, what was the direction of the motion? The direction of motion is straight. You draw a tangent here at this point A, it is just a straight. So this is the direction of the motion, but just the very next instance when it is going here, what is the direction here? It is like this. Okay. Again when it is coming here, what is the direction here? It is like this. Again when it is coming here, what is the direction here? It is like this. Again when it is coming here, what is the direction here? It is like this. Something like this. So at each and every point, you see that the direction of the tendency of the direction of the motion is changing, and that is being changed by the AC, which is the centripetal acceleration. Centripetal acceleration AC is nothing but v square by r, which is nothing but r into omega square. So this is my centripetal acceleration, right? Where v is the velocity and r is what? The radius. R is the radius and v is the velocity, okay, of the particle when it is accelerating. So centripetal acceleration is the acceleration directed towards the center of a circular path. It enables an object to continuously change its direction, okay, while moving in circular motion. It is always perpendicular to the velocity. Obviously, you see this is the velocity here, direction of the velocity, and it is perpendicular to the velocity vector, and is responsible for keeping the object in the curved path, because it is changing each and every moment, it is changing the direction. That is why, okay, the particle is in circular motion. Okay, now if I talk about, I have two kinds of circular motions. We will be talking about two kinds of circular motions here. So when we are talking about uniform circular motion and non-uniform circular motion, in both the cases, what is going to be constant? See, you will have two accelerations. One is AT, which is the tangential acceleration, another is AC, which is nothing but the centripetal acceleration. Now in both the cases, your centripetal acceleration is always going to be there. So here also centripetal acceleration is not equal to 0. Here also centripetal acceleration is not equal to 0. Because try and understand centripetal acceleration का function क्या है. Just now we saw what is the function of the centripetal acceleration. इस centripetal acceleration को हम लोग v square by r भी बोलते हैं, r omega square भी बोल सकते हैं. So AC is equal to v square by r और AC is equal to r omega square, है ना. तो ये जो सेंट्रिपिटल एक्सीलरेशन है इसका एक ही फंक्शन है, दैट इज इट चेंजेस द डायरेक्शन ऑफ द पार्टिकल एट ईच एंड एवरी मोमेंट, एंड इट इज बिकॉज ऑफ दिस सेंट्रिपिटल एक्सीलरेशन दैट द पार्टिकल इज अंडरगोइंग सर्कुलर मोशन. तो कोई अगर आपसे पूछे कि यूनिफॉर्म सर्कुलर मोशन है तो एक्सीलरेशन तो जीरो होगा, दैट इज अ रॉन्ग स्टेटमेंट. ट्राई एंड अंडरस्टैंड, बिकॉज सेंट्रिपिटल एक्सीलरेशन अगर जीरो हो गया तो वो पार्टिकल कभी भी सर्कुलर मोशन नहीं कर सकता. मेक इट अ स्टेटमेंट इन योर कॉपी. Centripetal acceleration has to be there because that this is the acceleration which is changing the direction of the particle at each and every moment, right? So AC तो रहेगा constant. कौन सा part zero होगा then? In case of uniform acceleration, your AT is going to be zero. AT means tangential acceleration, because this tangential acceleration is nothing but, what is this AT? This AT is nothing but dv dt, and here dv dt means, here v does not mean velocity, here we are actually taking just the magnitude of it, so it is the speed. So in case of uniform acceleration, I will have a constant speed, the speed is not changing, okay? The speed is not changing, so I can say that the tangential acceleration will become zero in case of my uniform acceleration, but in case of non-uniform acceleration, मेरा tangential acceleration भी zero नहीं होगा. So this is a very important conclusion, that in case of uniform acceleration, AC is not equal to zero, but AT is equal to zero, and in case of non-uniform circular motion, AC is not equal to 0 and AT is also not equal to 0, right? So the same thing is basically written here. Now you see, non-uniform के case पे you have the AC also, you have the AT also. That means आपका net acceleration कैसे आप निकालोगे? AT and AC they are perpendicular to each other. बस वेक्टर लगा दीजिए. वेक्टर में when the two vectors are perpendicular to each other, resultant का हम लोग कैसे निकालते हैं? Resultant is equal to root over the magnitude square. So root over AT square plus AC square, that is going to give you the A net. और ए नेट का डेफिनेटली अगर एटी इस डायरेक्शन पे है, एसी इस डायरेक्शन पे है, तो ए नेट मेरा इस डायरेक्शन पे होगा. ओके, एंड ए नेट व्हाट इज द एंगल if I measure the angle beta here, okay, with respect to the horizontal. So you can write that tan beta is nothing but AT by AC. लिख सकते हो ना, AT by AC, magnitude of A by magnitude of AT divided by magnitude of AC. ये आपका tan beta हो गया. Okay, now let us basically see this problem. A particle starting from rest moves in a circle of radius r. Particle ने rest से start किया. So starting from rest means initial velocity was 0. Okay, and he is moving in a circular path. So circular path means like this of radius r. Radius कितना r. This is the radius. It attains a velocity of v naught meter per second in nth round. Final velocity हो गया मेरा v naught. तो यहां पे मेरा wi क्या होगा, इनिशियल एंगुलर स्पीड मेरा क्या होगा, या फिर एंगुलर वेलोसिटी वाट एवर यू कॉल, इज v w ओमेगा आई से, ओमेगा इज इक्वल टू v by r. So vi by r, so vi is 0. So initial omega is my 0. फाइनल ओमेगा मेरा क्या होगा, v0 by r. This is my final omega, right? Now what is saying, it attains a velocity of this much in the nth round. nth round पे इतना velocity. So what is the displacement? Displacement, angular displacement theta. What is the angular displacement theta in the nth round? 2 pi into n. 2 pi into n. Now you apply omega naught, or I can say omega f v is equal to u plus at. So omega f is equal to omega naught. Omega naught is my initial. Omega f is equal to omega naught plus 8 at, है ना, alpha. So or else we can also say that so we are actually finding out its angular acceleration will be okay. This is better to use this. S is equal to, no, v square is equal to u square plus 2as. So v square is equal to means this omega f square is equal to omega naught square, because I need to find out the alpha directly, plus time तो given नहीं है ना, 2as alpha into theta, right? I can write this, ये लिख सकता हूं मैं. Now you put the value, wf means how much, I can say wf square is equal to w naught square plus 2 alpha theta. Omega naught square plus 2 alpha theta. तो ये इसका वैल्यू कितना रहा, what is this, v naught by r. So I can write v naught by r whole square is equal to, this is 0 to alpha, and how much was my theta, theta was my 2 pi into n. Okay, so from here you can say that v naught square by r square is equal to 4 alpha pi n. Okay, so from here the value of alpha, alpha is nothing but the angular acceleration, you will find v naught square divided by 4 pi n into r square. So this is the answer. So V naught square by 4 pi r square into n. V naught square by 4 pi r square into n. So option C is the correct option here. Okay. Now they are asking that an electron is moving in a circle of radius 2 meter with a speed of, so the speed is you see constant, 4 meter per second. So has they said that the speed is increasing or something? No, they haven't said anywhere that the speed is increasing. So it's a constant speed. Constant speed का मतलब क्या है? Constant speed का मतलब है कि it is uniform circular motion. Uniform circular motion का मतलब क्या है? Uniform circular motion का मतलब है AT, that is the tangential acceleration, has to be equal to 0. So we have one acceleration which is the centripetal acceleration acting towards the center. So इतना information बस एक line पढ़ के हम लोग निकल सकते हैं, just by reading one line. And anyway, if the electron is accelerating, then you know that it is going to radiate energy. So ultimately it will fall. So electrons हमेशा orbit पे घूमते हैं और orbit पे क्या होता है, energy conserve होते हैं, है ना? That is the concept from the concept of chemistry. Some chemistry we also know, I also know. So okay, now see, an electron is moving in a circle of radius 2 meter. So this is the radius 2 meter. Radius is 2 meter with a speed of, now the electron is basically moving with a speed of, what is the speed? The speed is 4 meter per second. Okay. Now you are asked to find out the acceleration of the electron. Now this is obviously what kind of motion? This is a uniform, you can write it, uniform circular motion, uniform circular motion. So your AT is going to be equal to 0. You will have only AC, and which is nothing but V square by R. What is your V square? 4 into 4. And what is your R? 2. 8 meter per second square. This is the answer. So your AC is going to be 8 meter per second square. This came in AIMS 2019. I hope that this class was very useful to you. Stay connected with Vision IIT NEET Academy for more classes. Thank you.